Welcome students. This session is about matrix multiplication. In this program, we are going to read two matrices, that is A of size m and n and B matrix of size p and q. These two matrices are multiplied and stored in resultant C matrix. Let's see how the program is written. So we require two matrices, that is A and B matrix, and the C resultant matrix to store the result of A into B matrix. And we require variables such as m and n to store the size of the A matrix, P and Q to store the size of the B matrix. I, J, K are used as the indices of the loop that is used for the matrix multiplication. So first, for matrix multiplication, we'll collect the size of the matrix A, that is m and n, and the size of matrix B, that is P and Q. To perform matrix multiplication, the size of the matrix should be compatible. To check the compatibility, the size of matrix A, that is n, and P should be equal. Otherwise, the matrix multiplication is not possible. So the next conditions will be, if n is not equal to P, then we're going to display a message telling that matrix multiplication is not possible and exit from the program. If n is equal to P, then we'll perform the matrix multiplications. So we'll start reading the matrix elements now. So we know the size of matrix A, that is m and n, and using the nested loops, we will read the elements of matrix A. Similarly, the nested loop is used to read the matrix B of size P and Q. To perform the matrix multiplication, consider the example A matrix and B matrix. Even though both the matrices are of uneven order, we can still perform the matrix multiplication since n and p are same. So by multiplying A and B matrix, we'll get C matrix of size m and q. So we'll start the nested loop with m and q and initialize all the C elements as 0. Next, to perform the matrix multiplication, each row of A is multiplied with each column of B. Now to get 58, the first row and the first column is multiplied to get 58 like this. So this has a summation of 3 products. So we require a K loop which keeps on changing the K values for A matrix and which changes the row values for B matrix. But the row values is always constant for A matrix and the column value is always constant for B matrix. So let's see how this K loop is used. So here, so the A matrix, the column number keeps on changing using the K loop, and for B matrix, the row number keeps on changing, whereas I and J remains constant. So by this statement, we can multiply each row with each column of the two matrices. So this process is continued for every other element of C matrix. So the first row and first column will give 58. First row and first column will give 58. Then the first row and the second column will give 64. Then the second row and the first column will give 139. The second row and the second column will give 154. So this process is continued for all the elements of C by using this nested. So the I and J represents the row and the column number of C matrix. So once the matrix multiplication is done, we'll displace the resultant matrix of C matrix of size m and q.